sometime later when they have no food. Okay, so there's a big concern of this, and it's not being directly researched very much so. Okay, this is just sort of an impressive. The scale of that slick is really what happened. This is why a lot of the oil initially disappeared. It was related to Hurricane Alex. So it pretty much was staying in one area, kind of moving back and forth with the synoptic systems, the storms, kind of regular sea breezes would push it to shore, and then some frontal system would come and shove it back out. It wasn't really going anywhere. Some of it was going shore. Then Alex came on, and it just sort of got pushed off. You can see her off to Florida, and then came on shore, and in many, many places. That was actually, it was not the capping of the well that made it go away at the sea surface. It was Alex. And you can see, it's available on the web, but if you look at the current pictures satellite that show very little oil, and then you look at ones before they cap it, it's almost about the same. Okay, it was about July 16th when it, because of the storms. So again, the information has not been very, it's been maybe more political than scientific in the media. Okay, so we had a very short time to get to the Gulf Coast with the NASA assets, about 5 days. And pretty much with the people I worked at NASA, the question was not who's going to pay for it. The question was not who's going to do it, it's just how can we make it happen. And so we did. Normally what would take 6 to 9 months of planning happened in 3 days. And so you can see the ER2 at the top, stratospheric plane. We brought that down. It has enormous phenomenal range. Okay, good. The next one. And we actually made it to the Gulf 1 day before the tar started hitting the beach, and surveyed the whole thing. So we have that before picture I mentioned before of the whole Gulf from Florida all the way to Texas. Never been done. We collected in 3 weeks more data than normally is collected in a year. Normally it takes 2-3 months. We got that down to 6 hours in terms of shifting gigabytes of data over across the NASA's network or backbone internetwork. A lot of work that went into making this happen. Okay. When we were leaving, some other government agencies were just setting up shop. Okay, so I like this picture because it, and it would just, if we'd waited, thank you, if we just waited for permission, it never would have happened. Okay, I mean, like official, bureaucratic kind of getting all the eyes. We figured we'd do that later. I like this picture because the man there looks so thoughtful. Of course, he really probably should have some breathing apparatus if he was long-term worried. There's oil in the water here, but this is sort of some of the things we don't know. It's like what the effect on the ecosystem, we really don't know. We're going to learn, but will it slowly kill off the grasses and then hurricanes will come and then there won't be protective barrier islands anymore, for example. And that's on the wetlands. The other is it's such a large spill. So many things are not the same in a large spill as a small one. So it starts changing weather, literally, because normally the wind blows over the ocean, and the ocean is water, so the water moves and the wind moves. When it gets over big oil, and you can actually see this out here if you go on a boat, suddenly the surface isn't mobile anymore because it's got oil. And so it calms down. The wind dies down right at the surface. It changes. And so one of the things is it actually changes local meteorology, which is not so local when you have a spill that's 100,000 square kilometers. But it changes it, which means there's a lot of things we don't know for this kind of a situation. And as it happened, BP did everything in their power, apparently, to prevent anyone from knowing. Okay, I assume that was their strategy. Okay. We'll figure out about the ecosystem recovery. That's from, there's a current NASA mission to both look at thick oil, but also to map again and see how things are dying or recovering or what's happening. And of course, hurricanes, when I wrote this, this was unknown, and we've figured out some of it. Okay, next. Okay, I'm gonna just go to the next one. And so this is just a map of our mapping of the area of the spill on the first day and doing the coastline. Just go to the next. This is, I wish I had a laser pointer. I'm going to pop over and talk loudly. Unless there's a laser pointer. Okay. So this is some of the data that we have with NASA, in which the color on the left here represents qualitatively thick versus thin oil. And on the right is actually quantitative. We know how thick the oil is here using the remote sensing. And this is at the incident site, which is over in this area. And you can see up here, two boats with some kind of a skimmer at the back, and there's sort of a clean area behind it. And right in the center of it, you can see there's some oil. So that's right over here enlarged. So this is the oil that they're collecting just leaking out the back. Okay, so this is an example of how not to use an oil boom and skimmer system. We have a much better usage on this day here. In this, it's hard to see there's a very tiny amount of oil leakage at the back. So one of the things that I was, when I was looking at this, I was preparing a paper for the Coast Guard on this issue. How do people train for an oil spill? Okay, well, you need oil. So how do the crews that go out there, they use simulated oil, they use wet bark chips and other things, or they just pretend there's oil and they do it on water. One of the advantages that we have here in Santa Barbara is our oil spill response people can actually train on real oil. Okay, a lot of people in the Gulf are now getting trained on oil and have learned a lot of lessons for Gulf oil. Will those be any use in the Arctic? I don't think so. Okay, so one of the things is this is part of the science, but one of the nice things we have here in Santa Barbara is we have very well-trained people because they actually have real oil to work on. Okay, next. Okay, and we here at UCSB have been taking advantage of the slicks, and so I like to say when I go out with my students to the slicks on the boat and I smell the fumes, I say, I love the smell of hydrocarbons in the morning. It smells like science. So here you can just see some of the things we did. On the left, we had a NASA plane flying, taking measurements, while with the NOAA Channel Islands boat, we were doing observations of methane coming out of the seeps. The bubbles are not photoshopped in. And the top center, we use sonar to kind of study the seepage and look at how it changes with time. And you can see on the lower right is when the 2005 La Conchita, there was all the rain and there was a lot of oil and oiled birds. And we had a very extensive oiling of the coastline at that time. So that's the photo in the lower right. And in the upper right is just some oil coming out of the seabed. So we've been taking advantage of this natural laboratory to try to learn about processes related to oil, hydrocarbons, gas in the environment, in the marine environment, collaborating with the Hydrate Consortium. We've been applying these techniques in, well, this last summer, I was at MC-118. It's about 10 miles away from the blowout site, okay, doing measurements of bubbles, oily bubbles rising from 1,000 meters, from 4,500 feet in the water column, trying to see what they were doing and learn from them. In the technical flow rate team, I said, why don't they send an ROV and go grab a sample of the oil and gas so we know what the ratio? And one of the other people on the team said, well, it's so deep, it would take forever. And I said, no, we did this summer. It was 40 minutes from the seabed. And then he stopped asking me questions. Now, the good question, of course, is why BP didn't do that. And I think the answer is really clear. They just didn't want anyone to know. And leave uncertainty in the numbers so that in court they can argue it forever. Okay, I think that was, the next one is probably my last. Oh yeah, here's just sort of a view off of Santa Barbara with some oil slicks going on, and then the next one. Okay, and just go to the next one. This just shows the technology that we developed and tried. And you can see there's a boom, an oil boom, and then there's bubbles. There's this bubble plume right next to it. And it turns out if you make a bubble plume in front of the oil boom, it improves the performance of the boom significantly. And so, but again, we have a place to test this here in the field, the seep field, where we don't need to get permission to dump oil into the ocean. It's natural. It's been going on for 500,000 years and so on. And we can learn from this to improve response in the Gulf of Mexico. I started doing this and then I kind of gave up, and I'd be happy to talk about it later. But life's been busy. A very small part of life, but it take over. Anyway, one of the things was a lack of coordination of the science and the data, which Congresswoman Lois Capps mentioned, is that if I wanted to find out someone was doing something, I had a lot of trouble finding that out. The only way is if I had a friend at the agency and I could call them up and say, hey, are you doing something? And they would say yes, and then we could coordinate. Very difficult to find the data, which means that if I'm trying to understand something, I don't know who to talk to. And this was never coordinated. Now you can understand 2 or 3 days of an oil spill response, and right now we're at really day 4 or 5. I know they say 105, but in a normal spill, the boat breaks apart, the oil's out, that's day 1. And no more oil comes out after that. We just hit day 1 just last week when they stopped, they capped it up. So now usually what happens in oil, everything gets worse for 5, 6, 8 months, and then it slowly gets better. So it's sort of a little bit premature sunny talk, you know, that things are getting better. That's not how oil spills work. And wishing it so doesn't make it so. So a lot of trouble coordinating with the scientists, trying to find data to improve the response. And we did not learn from this event, so we still have no idea what happens in deep sea. If there's another accident, we're going to be just as prepared as we were this time. And anyway, thanks. I'll take questions later.